Okay, in this video we're going to be discussing algebraic equations, understanding what they are, and then we're also going to talk about how do we solve what we call one-step equations. There will be another video on algebraic equations where we talk about how to break down more complex equations. Okay, so ultimately we've already talked about algebraic expressions. The only difference with an algebraic expression like x plus 2, right, that's an algebraic expression. Once we add an equal sign, now it becomes an equation, okay? So x plus 2 equals 10. So what is this equation really representing? It's saying some number plus 2 equals 10, right? Some number plus 2 equals 10. And when we do algebra, we're just trying to figure out, well, what number can I put here to make this equation be true, right? This needs to be equal to 10 as well. So with an equation this simple, right, if we think of it instead of an x as a blank box, plus 2 equals 10, right? Blank plus 2 equals 10. Well, we might realize the answer is 8, right? 8 plus 2 is 10. That's just our 10 pairs. Okay, so sometimes these equations, we don't necessarily need to do all the fancy footwork and all that, the algebra, but what I want to show you in this video is what are our basic tools in our toolkit when we're doing algebra, and how do we use those to solve equations like this. So we're going to backtrack just a tiny bit, and we're going to look at 4 different, seemingly very simple equations. Okay, I'm going to write the same equation 4 times. 5 equals 5. 5 equals 5. I won't keep saying it. Okay. Now we're going to ask the question, what happens if I do the same math operation to both sides of the equal sign? Does it stay equal? We're going to sort of prove this to ourselves, right? So let's start with addition. What's going to happen if I add the same number to both sides of my equation? Let's do plus 4. Well, 5 plus 4 is 9. 5 plus 4 is 9. Okay, why did I show you this? Well, what this means is that we can add the same thing to both sides of the equal sign, right? Think of this like a dividing line, and it will still be equal, right? So we're allowed to do that. We're allowed to add as long as we add the same value to both sides. It's also true with subtraction. What if I do minus 1? Well, 5 minus 1 is 4, and 5 minus 1 is 4, right? They're still equal to each other. Okay, so it works for addition, it works for subtraction. It actually works for multiplication as well. 5 times 3. 5 times 3. Well, 15 equals 15. Yep, still equal, right? And then here, it also finally, lastly, works for division, okay? 5 divided by 5. 5 divided by 5 gives me 1. Okay, so again, to reiterate, what we've seen is if I have an equation with an equal sign, I can add, I can subtract, I can multiply, I can divide. And as long as I do it to both sides of the equal sign, whatever I get underneath will still be equal to one another. So we can use this to help us solve equations. Like, let's take a look at this one, okay? And the way we do it is that we ask ourselves, well, what's happening to x? Or like, what math is getting done to x? And then once we answer that question, we're going to do the opposite. So if I were to look at this equation here and say, what is happening to x? What math is being done to x? Well, we're adding 2 to it, right? So we're going to do the opposite. What's the opposite of adding 2? Subtracting 2, right? These two are opposites of one another. These two are opposites of one another. So I'm going to subtract 2 and subtract 2. Okay, now over here, these two are both numbers, right? They're like terms. Positive 2 minus 2 is 0. So they sort of just disappear, right? We don't have to write the 0 because x plus 0 is just x. Okay, so when this totals up to 0, we're just left with x on this side. And then here, 10 minus 2 gives me 8. All right? So, again, conceptually, we could think about it like we're trying to get rid of everything on this side that isn't x, right? When we have just x left over by itself, that's how we're able to know, well, what is x equal to, right? What number plus 2 would give me 10? In this case, 8. Okay, so up here I've given 2 more examples of what we call one-step equations. Okay, remember that the goal is just to get x to be left on its own on this side of the equal sign, right? Get x, we think, well, okay, we need to get rid of this 3. We need to get rid of this minus 11. Okay, we'll take it one at a time. Let's start over here. Now, the way we end up getting x by itself, right, we need to get rid of this 11. And we ask, okay, well, what happens to x? We're subtracting 11. What do I need to do to this 11 to make it a 0 to get rid of it, right? The opposite. The opposite of subtracting 11 is adding 11, okay? Now, because I added 11 over here, I have to do it on this side as well. Otherwise, I can't put this equal sign here, right? We talked about as long as I add the same thing to both sides, we're good, okay? So negative 11 plus 11, or 11 minus 11 is 0. So cancels out, leaving me just with x. And then 21 plus 11 is 32. We can check that if we want, right, by substituting in. X minus 11 equals 21. Well, let's put 32 here. Does that work? 32 minus 11 gives me 21, right? Yes. 32 is the value that I can put here for x to make this equation true, okay? Let's take a look at this one. Well, what's happening to x? 3x means 3 times x. So in order to get rid of this coefficient of 3, we need to do the opposite of 3 times x, which is 3 divided by, which is dividing by 3, right? Let's divide by 3. 3 divided by 3 leaves me 1x, but I don't remember when we have a coefficient of 1, I don't need to write it. So we're just, again, left with x, and 21 divided by 3 is 7. Okay, let's take a look at 2 more examples. X over 11 equals 12. Okay, what's happening to x here? What math is being done to x? We're dividing by 11. So we need to do the opposite. What's the opposite of division? Multiplication. So we're going to multiply by 11 over 1 times 11. Okay, see, I'm doing the same thing on both sides of my equation. Now remember, with multiplying fractions, these cancel out. So we're just left with x. And 12 times 11 is 132. Okay, let's do one last one involving addition again. X plus 41 equals 30. So some number plus 41 equals 30. Okay, remember, the question we're always asking ourselves, what is happening to x? I know I keep saying it over and over again, right? But that's what we're always asking. What's happening to x? And then we'll do the opposite. So what's happening to x here? We're adding 41. The opposite of adding 41 is subtracting 41. And we always do it to both sides of the equal sign. Okay. These cancel out, leaving me with just x. Over here, 30 minus 41. Well, the number I'm taking away is bigger than the number than 30, right? So I know my answer is going to be negative. So let's use a friendly fact that's easier. 41 minus 30 would give me 11. So 30 minus 41 is negative 11, all right? X is equal to negative 11. So I know that this was fairly quick, but we're going to, again, like I said, have another follow-up video that goes deeper into this concept. But I wanted to take some time to introduce this idea of algebraic equations and go over how do we solve one-step equations, because right, they're going to get a little more complex, but the basic process doesn't change. The only tool that we have in our toolbox when we're doing algebra is adding, subtracting, multiplying, or dividing and doing it to both sides of the equal sign, right? We're always subtracting 41 from both sides or dividing by 3 on both sides, okay? So we'll continue to talk about this more in the next video. Thank you again, as always, for watching, and I will see you in the next one.